It's now more than a century ago that Mr. Thomason first began to make gas engines. He soon extended his activities to include the design and production of reciprocating compressors. And what started out as a small company has grown into a major supplier with sales outlets and service at strategic points around the globe. Our customers are engaged in refining, gas and oil exploration and production, as well as petrochemical and chemical industries. The tailor-made systems we supply include reciprocating compressors and centrifugal compressors, with full service round the clock all over the world. A reciprocating compressor consists of a frame, a crosshead guide, and a cylinder. The main moving parts are the crankshaft, connecting rod, crosshead, piston rod, and a piston. The piston is equipped with PTFE-based rider rings, which bear its weight. Piston rings act as a seal between the high and low pressure sides of the cylinder. Depending on the process, the piston may be lubricated or non-lubricated. For non-lubricated compressors, process and gas conditions accelerate rider ring wear unpredictably, in a way similar to the action of an eraser. After years of research with marginal improvement in material properties, Thomason developed a revolutionary new design, the free-floating piston. The principle of this technique is that the process gas itself carries the weight of the piston. During the compression stroke, it fills with process gas. Due to the pressure difference, gas flows out at the bottom, ensuring that there's no physical contact between rider rings and cylinder liner. Wear is thus reduced to practically zero, resulting in much longer rider ring lifetimes. The design of the piston has also been specially adapted. The rider rings are now relocated in between the piston rings to create a constant pressure. Regular compressor valves that react to differences in gas pressure are located in the piston faces, enabling gas to enter into the piston. Flow nozzles have been integrated in the rider rings and a profile machined on their lower surface to create a bearing layer underneath the piston. As the thickness of the bearing layer is in the order of microns, the flow required to lift the piston is marginal compared to the compressor's capacity. The new construction compensates for this, so net compressor capacity is unaffected. After the design had been subjected to rigorous in-house dynamic testing, a successful pilot test followed in a production hydrogen compressor at a customer's site. The key advantages of the free-floating piston include practically no rider ring wear, increased lifetime of piston rings and stuffing box elements, and no need for cylinder lubrication. The design can be applied to existing compressors, and it's fail-safe. Maintenance costs are reduced, while reliability and availability are increased. The industry's requirement for at least 3 years of uninterrupted running time with non-lubricated cylinders is finally within reach. Putting the principle into practice. Thomason Compression Systems free-floating piston technology.